Welcome listeners again to our next topic of discussion, that is engineering geology, and this is under the series of lectures on fundamentals of geology. So, the next topic that I would like to discuss with you is the engineering geology. Obviously, as the subject name suggests, it is a mixture of obviously geology and the subject of engineering. So, definitely whenever we are referring to engineering geology, we are actually referring to the science that is applied to assess slope stability, that how far some slope, be it in some mountain, be it in some hill station, be it some coastal slope, wherever it is, or be it within the city even, how far a slope will be stable or not. Because why? Because we need to assess that whether that particular area is suitable for building a dam, that area is suitable for building any tunnel, or even if you need to join the two sides of a river, for example, that means you need to build a bridge, then also you have to consider this engineering aspects apart from the geological features that are intricately associated with them. So, this is a relatively, you can say, new means you can say new avenue in the study of geology, because this directly relates to the application of geology along with the concepts of engineering science, and that finally will result into you can say an idea that whether I can develop some kind of infrastructure or some kind of this large scale dams or tunnels or bridges, which are definitely very much useful in our daily life. So, that is why I thought to discuss this aspect of the subject as well a little bit. So, to start with, that engineering geology is obviously a fascinating field that bridges the gap between geology and engineering, like I was mentioning. Engineering geology is the application of geology to engineering studies. Its primary goal is to ensure that geological factors related to the location, design, construction, operation and maintenance of engineering works are recognized and accounted for. So, the role of engineering geologist, obviously the engineering geologists provide recommendation, analysis and design related to human development and various structures. Like I was saying, it has a direct impact on the society itself. So, the earth structure interaction, they study how natural processes might impact human made structures and vice versa. Their work spans from planning to environmental impact analysis and management, design, construction, and even if a tunnel or dam has been made, then obviously the post construction phases as well. So, engineering geologists assess geological hazards, material properties, landslide, slope stability, erosion, flooding, dewatering, and even sometimes seismic risks. So, the main objective of this discussion of engineering geology. So, the principal objective of engineering geology is the protection of life and property against damage caused by different geological processes. They play a crucial role in ensuring safety and stability in large scale or small scale infrastructural projects. So, the first thing that we need to discuss is the stability of a slope, because that is very essential, be it a horizontal one, be it a vertical one, or in between any slope with any angle. It is extremely necessary to assess that before construction of any it means infrastructural project, even in for example making a house in a hilly terrain. That is, for that also you need to have a clear idea of the slope stability, that if the slope is stable, then only it is wise to build a house or even bigger scale projects on that slope. Otherwise it is extremely risky, even if it is made up of concrete or whatever material you are using. So, by definition, slope stability is a critical aspect of engineering geology that deals with the ability of a slope or hillside to withstand the downward movement or collapse of soil and rock materials. Slope stability refers to the condition in which an inclined slope can withstand its own weight and external forces without experiencing displacement. So, then I can say that if there is no effect of the external factors on the slope, then it is possibly it is a stable slope. It involves principles from rock and soil mechanics, geotechnical engineering, and obviously engineering geology. So, there are various ways a slope can go under failure. Obviously, we talked about landslides and different kinds of mass wasting processes, even without any external factors, how we have seen earlier when we discussed about mass wasting, that simply under the action of gravity, how your slope can slide, rocks can fall from above, your different cliffs might become unstable and they can glide as well. So, there are various types of landslides that we generally study to again assess the stability of a slope, like we discussed in the case of our discussion on mass wasting. I will not again repeat that. So, just to mention, you have several types of landslide like rock fall, rock slide, debris flow, mud flow, earth flow, creep, slump, and even some complex landslide when 2 or 3 or more processes are involved in the same landslide event. So, factors that influence slope stability are obviously the geology and the soil properties. Hydrological conditions means the water content in the soil or in the kind of the secondary porosities like your joint plains and all those places. Slope geometry, the angle of repose we discussed. So, if the angle is exceeding the angle of repose, it is possibly that slope will no longer be stable. Seismic activities like earthquakes and other seismic activities might also trigger a landslide, and that is actually due to the instabilities that got triggered that were already present in that particular slope. So, seismic activity can also trigger landslides. Human activities, which are now the main focus or the main problem of the modern times, is human activities like excavation, construction, mining or logging can alter the stability of slopes and lead to instability and failure. Again, this is extremely important because if there is no pre-planned or very means you can say planned idea through which you are excavating a zone or constructing any road, it is highly it can that road or that cliff, rock cliff across which you have made this road can become highly susceptible to this kind of slope instabilities. Again, vegetation plays a very important role because vegetation always try to hold soil and other materials together. So, removal of vegetation can cause instability and contribute to the slope failure by reducing soil cohesion and increasing water flow. Climate change induced phenomena like heavy rainfall, torrential rains, sometimes droughts and changes in temperature can also contribute to your slope failure. Other factors like different processes of mechanical and chemical weathering like erosion, freeze thaw cycle and natural slope movement over a period of time may also result into slope instabilities. Then they are assessed based on several techniques. I will not go into the detailed techniques because these techniques are mainly used at advanced level, but here I will be mainly dealing with the understanding of the subject and how just by looking at your geological information, how you can assess some of these things, that whether a dam will be stable or not, whether a tunnel will be stable or not, whether some bridge will be stable or not, or what are the preconditions or what are the requisites for the construction of a dam or tunnel or a bridge. So, there are different analyses, just to mention limit equilibrium analysis, finite element analysis, shear strength reduction analysis, probabilistic analysis, and some empirical methods are also available to judge the slope stability of a region. So, but I will go like I was mentioning that I will just go by the fundamental idea from a geologist perspective. that the attitude of the beds and stability of a slope has a very interconnected dependence on one another. So, if the first one you have a orientation or dip of the beds in A towards the right side of your screen, you can, and you have some unconsolidated material that are present on this right side dipping or right side sloping surface. This unconsolidated material that if by chance due to lack of, you can say, analysis or lack of information, you are making some kind of a road or some kind of a terrace just above that, it is very likely that this unconsolidated bed will not at all be stable. So, in time of a torrential rainfall or some percolation of water, this unconsolidated bed might simply get destabilized from its present position. Dressing the slope of the same to make it stable. Sometimes what happens, some drainage channels to make ways for the water, so that the water does not percolate within this weathered and unconsolidated sediment cover, so that the water does not percolate through it. Some drainage channels are prepared on the surface or on the top surface of these terraces or this top surface of these road cuts, that so that the whatever water is coming down during a rainfall or even a torrential rainfall, they get drained through these channels directly to some nearby river or some other pond or stream, so that it does not penetrate or infiltrate through the soil, and there is no chance of creating any further instability. This C, then coming to C, this one, stable slope on horizontal beds. So, always horizontal beds are very, you can say, favorable for the stability of any slope. So, if there is a horizontal bed, so there will be no slip kind of thing, there will be no slip, there is no chance of slipping horizontal beds unless there is a large scale, you can say, seismic activity or something. Apart from that, this is extremely stable. So, you can prepare or cut rock surfaces like this, you can make road cuts like this when there is a horizontal bed, something that is shown in this figure. Then you also can have stable slopes on inclined beds if the dip of the bed is just on the reverse direction or on the opposite direction of the slope of the cut. So, if you want to you are cutting some edge of the cliff for the construction of a road or for any other purpose. So, if the beds that are present inside the topsoil or inside the beds that are present, if they are dipping just away from the direction of the slope of your road cut like this, if this is the slope of your road cut, then if the beds are at an high angle or perpendicular to the direction of the dip of the slope, then obviously these are extremely stable horizons. So, stable slope you will get in case of this one E. So, stable slope again on dipping beds where inclination of the bed is greater than that of the slope. Again the same condition, if I just change the dip a little bit, that the dip of the bed is less than the angle or the slope of this surface, then this surface will become unstable, because of the there is a chance of simply gliding of these layers with respect to one another, leading to instability in the slope. Then you have this example where your stable slope is perpendicular to the direction or the dip direction. So, you have a slope in this direction, and so the strike of the slope will be something like this. The dip direction is towards this side, and you have the bed orientation which are at perpendicular relationship. So, it is not, it is now not opposite, the opposite one is also stable. If the orientation is perpendicular, then also it is quite stable. So, and the final one, that the stable slope above water table and unstable slope below water table. So, if you have this thing, a slope like this above the water table, so obviously the chemical weathering processes that are operating at the or beneath the water table will not take place here, but if there are slopes which are beneath the water table, obviously some kind of chemical weathering will go on there. So again, it is just the position of the slope where it is situated above the water table or beneath the water table. So based on this orientation, so you will be, whenever you will be looking into this thing in a geological perspective, you will be mainly looking at the orientation of the beds and other factors like the water table level, and also the presence of, if there are some zones or horizons of unconsolidated sediments. So these are the geological considerations that are important to reflect the stability of a bed. But if you want to do a very precise quantitative analysis, then you have to go for the different methods that we just mentioned. We have not discussed that in detail, and that can be only discussed whenever you are looking into engineering geology at much advanced level. So here, for our understanding purpose, we will be only looking, or we will be comparing between the orientation of the bed and the orientation of the slope you are dealing with. So based on that, you can say whether your slope is stable or unstable in nature. To mitigate slope instabilities, to reduce risk, we can improve the drainage and vegetation cover. We can construct walls or stabilization structures, alter slope geometry through grading or excavation. We can reduce the angle of a slope. Simply, if I cut the upper part of that slope, obviously it will become a gentler. So a steeply dipping slope, there is chances of instabilities are more in comparison to a gently dipping one. In extreme cases, consider relocating infrastructure away from high risk zones. So if there are no way you can control this instability, in that case it is better to shift away from that location. You can find an alternate path for your, for example, road cut or something else, or even for you can say as a foundation rock, you should avoid those slopes which are already, you know, that these are unstable in nature. So the idea of foundation rock now, because always whenever you are making a small house, or you are making a large scale dam or tunnel or even bridges, obviously the idea of the foundation on which the rest of the project is based on, it is extremely important. So the idea of rock foundation or the foundation materials is important. So your foundation rocks are the bedrock or substratum upon which the structures are built or will be built. They form the base or support for buildings, bridges, dams and other infrastructural projects. These rocks, definitely they are selected in such a way that these rocks provide stability, load bearing capacity and resistance to deformation. The choice of foundation rock depends on the factors like geological condition, load requirement and type of structure. So obviously again, if you are talking about the foundation rock, we know there are only three kinds of rocks: igneous rock, sedimentary rock and metamorphic rock. So your igneous rock examples that are used as foundation stone include granite, basalt. You can say the full or the whole city of your Mumbai is actually resting on the Deccan basalt. That's why it provides a very strong foundation for those high rises that you can see along the coast of Mumbai. And metamorphic rocks like marble, some gneisses, they are also very favorable foundation stones. Some schist are favorable to foundation, but all kind of schist are not favorable foundation rocks. Talking about your sedimentary rocks, obviously your sandstone, limestone and shale will have a larger you can say strength, and obviously they can be used if you are making some infrastructural project in some sedimentary terrain. So obviously, as we have discussed much earlier, the 75% of the surface area of the earth is covered by, land surface of the earth is covered by your sedimentary rocks. So you have to rely on sedimentary rocks as well, and likewise you have to select. So the properties that are considered for selecting the foundation rock is the strength, stability, permeability, uniformity, jointing and fracturing. So if there is an uniform strata with no discontinuity in it, no breakage in it, obviously it will be a better foundation in comparison to a fractured and jointed bed. Obviously, the permeability, if the permeability is less, definitely the percolation of the water or the movement of the water that is present or even groundwater is minimum. So, definitely it will not induce any kind of weathering into the impermeable rock. So, impermeable rocks are also considered as good foundation rocks or materials. Engineering considerations include site investigation, foundation design, site of selection, that where you will get this kind of foundation rock, what is the, for example, you are building a bridge. So, what is the narrowest channel width that can support, with the help of good foundation rock, that can support a bridge in long term. Then obviously there are other, you can say, considerations like environmental impact assessment. So, these are the role of a engineering geologist. Common foundation materials apart from the rocks, common foundation materials since the, I'll say, since the early Stone Age, or even since definitely since the means Iron Age, people started using concrete. Earlier people used to rely much on timber or wood, but later on in the Iron Age we are now depending on concrete, steel, and your gravel and crushed stone. They are mixed sometimes in a very, you can say, they are melded together, they are mixed to give you a rock or material, foundation material, that is even sometimes more stronger than a normal igneous rock or a normal metamorphic rock. It is possible to get this kind of blending with the help of cement, sand, and other materials that can bind together very strongly, like we generally prepare concrete out of it. So, these are definitely your common foundation materials. So, now I will go into the second part of our discussion, when we will be mainly dealing with your dams, tunnels, and bridges, and what are the geological considerations before building such a large infrastructure. So, thank you for this part of discussion.